Hello friends, welcome to my third and last lecture on review of Z transforms. In this lecture we shall discuss the inverse Z transform of some complicated rational functions and also we shall see how we can solve the difference equation where we will have to take while taking the inverse Z transform some complications might arise. So, let us first discuss the inverse Z transform of the rational function Z cube minus 20Z over Z minus 2 whole cube into Z minus 4. You can see that this rational function, so this we can call as uz, okay. So, uz equal to Z cube minus 20Z divided by Z minus 2 raised to the power 3 into Z minus 4. Now, we can see that this uz has got a pole of order 3 at Z equal to 2 and a pole of order 1 at Z equal to 4. Okay. So, what we will do while taking the inverse Z transform, the usual technique is that we first consider uz over Z. Okay. uz over Z, and when you consider uz over Z, what is left is Z square minus 20 divided by Z minus 2 raised to the power 3 into Z minus 4. Now, why we do this? Because if you straight away you break uz into partial fractions, then the partial fractions will not come in the standard form. We know that Z of a to the power n, okay. Z of a to the power n is Z over Z minus a, okay. Z of n times a to the power n is Z over Z minus a whole square into a z. Z of n to the n a to the power n is a z over Z minus a whole square, okay. Z of n square a to the power n, this is equal to a square z plus a z square divided by Z minus a whole cube. So, there are some standard forms of the Z transforms of the sequences a to the power n, n a to the power n, n square a to the power n. So, if you straight away you factorize uz into partial fractions and the partial fractions are of the form say a over Z minus a plus b over Z minus a whole square and so on, then when we take the inverse Z transform, it will not come in the standard form. We will like to consider the fractions of uz in such a way that they come in the standard form. So, we can apply the standard formulae, and you can see that in the Z transform of a to the power n or n a to the power n, n square a to the power n, Z is common in the numerator, Z here also we have a z, here we can take out z. So, we will have a square plus a z, okay. So, what we will do, we will consider uz over z and whatever remaining partial rational function we have, that we bracket into partial fraction. So, uz over z is z square minus 20 over Z minus 2 whole cube into Z minus 4. So, this is how we write uz over z, z square minus 20 over Z minus 2 whole cube Z minus 4, and this is so corresponding to Z minus 4 we will write the partial fraction a over Z minus 4, then Z minus 2 raised to the power 3 we will write as Z minus 2, one will be the fraction Z minus 2, the other will be Z minus 2 whole square. Now, here we could write C over Z minus 2 whole square, but when we will take the inverse Z transform, then this Z, okay, this Z we will multiply on the right side, and here we will get Z over Z minus 4 into a, Z over Z minus 2 into b, and here we will get C times Z over Z minus 2 whole square. When we take the inverse transform of uz, Z over Z minus 4 will be 4 to the power n, inverse Z transform of Z over Z minus 4 will be 4 to the power n, inverse Z transform of Z over Z minus 2 will be 2 to the power n. Here inverse Z transform of Z over Z minus 2 whole square we cannot write directly. If you want to write, then Z of n a to the power n is a z over Z minus a whole square. So, and here we have only Z over Z minus 2 whole square. So, we will have to divide n a to the power n by a, okay. Inverse Z transform of Z over Z minus 2 whole square, this will be n a to the power n, that means n2 to the power n divided by 2. What we do is we in the beginning itself this scalar a, okay, which is 2 here, we take along with the constant c. Okay. So, c into 2 over 2 minus z whole square, 2 over z minus 2 whole square. So, when you will multiply this by this z right side by z, then it will be 2 z over z minus 2 whole square, and so we will be able to write the inverse z transform of 2 z over z minus 2 whole square directly as n into 2 to the power n. Now, here corresponding to this z minus 2 whole cube, z minus 2 whole cube, if you compare with this expression, okay, or with this expression, there what we have, this z we have already taken, okay, 1 z we have already taken from here. So, what is left is a z plus a square z plus z, okay, a square z, 1 z we have already taken. So, that means we have a square plus a z, okay, a square plus a z we need here, okay, a square plus a z we need here. So, z is equal a equal to 2, that means we have 2 to the power 2 means 4 plus 2 z, okay. So, we need in the numerator 2 z plus 4. So, what we do is along with the constant d which we need to determine, okay, from the identity, we multiply d by 2 z plus 4 over z minus 2 whole cube. So, while we shall write u z, okay, right side will be a times z over z minus 4, b times z over z minus 2, c times 2 z over z minus 2 whole square, d times 2 z square plus 4 z divided by z minus 2 whole cube, and we will be able to write its inverse of 2 z square plus 4 z over z minus 2 whole cube directly as n square into 2 to the power n. Okay. So, that is the technique to factorize this u z. Okay. U z to factorize u z, we first consider u z over z, and then the partial fractions are written in such a way that we, while taking the inverse z transform, we can directly put the values, we can use the standard formulae. Okay. Now, corresponding to this z minus 4, okay, z minus 4 factor, the value of a can be determined directly. You need to consider only z square minus 20 divided by z minus 2 whole cube. You do not have to consider z minus 4. In the remaining rational function, you put z equal to 4, you get the value of a. So, z square minus 20 divided by z minus 2 whole cube, when you put z equal to 4, gives you 16 minus 20, 16 minus 20 divided by 4 minus 2, that is 2 whole cube. So, 8. Okay. So, this is equal to minus 4 by 8, and that is equal to half, minus half. Okay. So, this is minus half. So, we get the value of a, and for the values of these b, c and d, we write this equation. Okay. So, we have write the identity z square minus 20, then you take the LCM, a will be multiplied by z minus 2 whole cube, b will be multiplied by z minus 2 whole square into z minus 4, 2c will be multiplied by z minus 2 z minus 4, and d will be multiplied with 2z plus 4 into z minus 4. Now, this is an identity, it is valid for all values of z. So, we to get the values of a, b, c, d, we equate the coefficients of like powers of z on both sides. So, first we equate the coefficient of z cube on both sides. So, when you see here, the coefficient of z cube is a, and there is no z cube term here, there is no other z cube term except here. Okay. The coefficient of z cube is a here, this is we have coefficient of z cube here also. So, coefficient of z cube is a, and here we have b. Okay. So, a plus b equal to 0. Okay. So, one equation is a plus b equal to 0. Now, we have a equal to minus half. Okay. A equal to minus half. So, b equal to half. Now, let us equate the coefficient of z square both sides. Then when you cut the coefficient of z square both sides, here the coefficient of z square is 1, on the right side you collect the coefficient of z square, you get minus 6a minus 8b plus 2c plus d, and so we have this equation 1 equal to minus 6a minus 8b plus 2c plus d. Now, next we equate the coefficient of z both sides, there is no z term here. Okay. So, the coefficient of z here is 0, here on the right side when you collect the coefficient of z, you get this. Okay, 12a plus 20b minus 12c minus 4d. So, left side there is no term in z. So, we have 0 equal to 12a plus 20b minus 12c minus 4d, and then lastly we equate the constant both sides. On the left side the constant is minus 20, okay. The constant is minus 20, and on the right side the constant is, here it is minus 8a, here it is minus 16b, here we have 8 into 2 16c, and here we have minus 16d, okay. So, we have this equation, minus 20 equal to minus 8a minus 16b plus 16c minus 16d. Now, we have the values of a and b, and there are 3 equations. We need to determine only 2 constants c and d, okay. So, we can determine from them, putting the values of a and b in equation 1 in this equation. When you put the value of a and b in this equation, okay, what you get is, so putting the value of a and b in this equation 1, this one, okay, we get c plus d equal to 1. Similarly, let us put the values of a and b in equation 2. In this equation, we get the relation between c and d as 3c plus d equal to 1. Now, this equation is c plus d equal to 1, this is 3c plus d equal to 1. So, from these 2 equations, it turns out that c is equal to 0 and d equal to 1, and thus we get the value of u z by z. U z by z, you put the values of a, b, c, d, okay. So, u z by z becomes this. Minus 1 over 2 into z minus 4, 1 over 2 into z minus 2 plus 2z plus 4 divided by z minus 2 whole cube. Now, you can see if you just multiply by z this equation, you will get the expression of u z in the standard form, where we can directly use the formula for the inverse z transform. So, u z is equal to minus z over 2 times z minus 4 plus z over 2 times z minus 2, 2z square plus 4z divided by z minus 2 whole cube. So, we get this, okay. And now, let us take the inverse z transform. So, taking inverse z transform, z inverse u z, okay, z inverse u z will be equal to minus half z inverse z over z minus 4 plus 1 by 2 z inverse z over z minus 2 plus z inverse 2z square plus 4z divided by z minus 2 whole cube, okay. Z inverse of z over z minus 4 is 4 to the power n. So, we have minus 4 minus half into 4 to the power n, then z inverse of z over z minus 2 is 2 to the power n. So, we have half into 2 to the power n. Here we have z inverse of 2z square plus 4z divided by z minus 2 whole cube is n square 2 to the power n, because let us again recall z transform of n square a to the power n is a z square plus a square z divided by z minus a whole cube, okay. So, in this you put z in this you put a equal to 2, you get inverse z transform of 2z square plus 4z divided by z minus 2 whole cube as n square 2 to the power n. So, this is how we can find the inverse z transform of u z. Now, let us solve this difference equation. Y n plus 2 plus 6 y n plus 1 plus 9 y n equal to 2 to the power n, where we are given that y naught and y 1 are equal to 0. Let us take z transform of y n sequence as y z, then taking z transform of the given difference equation, we get z square z of y n plus 2. Let us recall the advanced property, z of y n plus 2 by advanced property is z square into z of y n, okay, which is y z minus y naught minus y 1 over z, okay. So, we get z square by z minus y naught minus y 1 over z, then y n plus 1, z transform of y n plus 1 by advanced property z times y z minus y naught. So, we get this, okay. Then z transform of y n is y z, so 9 by z, z transform of 2 to the power n is z over z minus 2, okay. Now, substituting the value of y naught and y 1, y naught is 0, y 1 is 0, okay. So, we get y z times z square plus 6 z plus 9, okay. We get y z times z square plus 6 z plus 9 equal to z over z minus 2. z square plus 6 z plus 9 is z plus 3 whole square. So, we get by z, okay, by z equal to z over z minus 2 into z plus 3 whole square, okay, that is this. Okay. Now, as usual we have to we have to consider by z over z. Okay. So, let us consider by z over z, then we have the rational function 1 over z minus 2 z plus 3 whole square, this we have to write in the standard form. So, a over z minus 2, b over z plus 3 and c over z plus 3 whole square. Here in the last example on inverse z transform, corresponding to 1 over z minus a whole square, okay, we had taken the fraction as c times a z divided by z minus a whole square. This z we have already taken in by z over z. So, we have to consider c times a. Okay. What we can do here, that this is a over z minus 2 plus b over z plus 3 plus c over z plus 3 whole square. You might consider here c times minus 3, because a is minus 3 here, and if you do not take minus 3 here along with c, then you will have to divide while taking the inverse z transform of z over z plus 3 whole square by minus 3. So, here we have not written minus 3 separately. So, that I will do in the end while taking the inverse z transform. Okay. So, now let us find the values of a, b, c here. So, the value of a can be found directly, a because z corresponding to z minus 2, okay, the power of z minus 2 is 1. So, when you have a simple pole at z equal to 2, the value of a can be found directly 1 over z plus 3 whole square, in that you put z equal to 2. So, when you put z equal to 2 in 1 over z plus 3 whole square, you get 1 over 25. So, a is 1 over 25, okay, and the value of c can also be found directly, because the power of z plus 3 is 2 here, and here also the power of z plus 3 is 2. So, in the remove z plus 3 whole square from this expression, in the remaining rational function you put z equal to minus 3. So, 1 over z minus 2, okay, c equal to 1 over z minus 2, when you put z equal to minus 3 gives you minus 1 over 5. Okay. So, we get the value of c as minus 1 over 5, but we still need the value of b. For that we will have to write the identity. You take the LCM on the right side, okay, and then equate both left and right side. So, 1 will be equal to a times z plus 3 whole square plus b times z minus 2 z plus 3 plus c times z minus 2. Okay. So, this is what this equation we get, and from this we can easily find the value of b, because we know already a and c. So, you can equate the constant term both sides. The constant term on the left side is 9a minus 6b minus 2c, on the right side it is 1. So, 9a minus 6b minus 2c, when you put the values of a and c as 1 over 25 and minus 1 over 5 gives v equal to minus 1 over 25, and hence you can get the value of by z. Okay. By z is now a times z over z minus 2. So, you have 1 over 25 z over z minus 2, here b is now minus 1 over 25. So, we get minus 1 over 25 z over z plus 3, and c is now minus 1 over 5. So, we get c that minus 1 over 5 times z over z plus 3 whole square. Now, let us take the inverse z transform here. Okay. So, inverse z transform of by z will give us the yn sequence. So, z inverse of by z will be equal to 1 over 25 z inverse of z over z minus 2, that is 2 to the power n minus 1 over 25 z inverse of z over z plus 3. So, minus 3 to the power n. Okay. Now, let us find minus 1 over 5 z inverse of z over z plus 3 whole square. Okay. Now, we know that z inverse of a z over z minus a whole square, this is equal to n times a to the power n. Okay. If you take a equal to minus 3, okay, then if you have minus 3 z upon z plus 3 whole square, then you can write directly n times minus 3 to the power n, but here we have z only. So, z inverse of, you can write z over z minus a whole square from here as n a to the power n divided by a. Okay. So, if you take a equal to minus 3, what we will get? Z inverse of z over z plus 3 whole square will give us n times minus 3 to the power n divided by minus 3. Okay. So, this will be last term will be minus 1 over 5, okay, this minus 1 over 5 into 1 over minus 3 and then n times minus 3 to the power n. Okay. So, this is 1 over 15. Okay. So, we can now write z inverse of by z inverse of by z we can write. So, this is equal to 1 over 25 2 to the power n minus 1 over 25 minus 3 to the power n and then plus 1 over 15 n times minus 3 to the power n. Okay. So, this is what we have here. Okay. By n equal to z inverse of by z, this is by n. Okay. This is equal to by n. So, the sequence by n is given by 1 over 25 2 to the power n minus 1 over 25 to minus 3 to the power n plus 1 over 15 n times minus 3 to the power n. Now, let us take one more question. Here we have difference equation u n plus 2 minus 2 u n plus 1 plus u n equal to 3 n plus 5. Okay. So, here z transform of u n we denote by u z. We are again given u naught u 1 equal to 0. So, taking z transform z of u n plus 2 by advanced property will give us z square u z minus u naught minus u 1 by z and then minus 2 times z of u n plus 1 will be z times u z minus u naught plus z of u n will be u z and z of n, okay, 3 times z of n plus 5 times z of 1. We know that z transform is a linear operation, okay, it satisfies linearity property. So, z transform of 3 n plus 5 is 3 times z of n plus 5 times z of 1, okay, and we know that z of a to the power n equal to z over z minus a when mod of z is greater than mod of a. So, put a equal to 1 here. So, then this implies z of 1 to the power n equal to z over z minus 1, okay, or z transform of 1 equal to z over z minus 1, okay, and z transform of n, okay, z transform of n we can write z transform of n is z over z minus 1 whole square. I got it from z transform of n a to the power n, z transform of n a to the power n, in that I put a as 1. Okay, but it can be found directly, okay, z transform of n as z over z minus 1 whole square. So, this is equal to this, okay, 3 times z over z minus 1 whole square plus 5 times z over z minus 1. Okay. So, I have made use of these formulas. Okay. Now, we will need the formula for z of n square and z of n cube later on, okay, when we simplify this. Now, this left hand side is z square minus 2 z into u z plus u z. So, this is z minus 1 whole square. So, left side is z minus 1 whole square into u z, okay, and right side you can see this is z minus 1 whole square and we have 3 z into 3 z plus 5 z into z minus 1. Okay. So, we get 3 z minus, so we get 5 z square minus 5 z square minus 2 z divided by z minus 1 whole square. Okay. So, this z minus 1 whole square we divide here on the right side and get u z equal to 5 z square minus 2 z divided by z minus 1 to the power 4. Okay. So, u z comes out to be 5 z square minus 2 z divided by z minus 1 to the power 4. Okay. What we will do again? We will write uz by z. Okay, we will write uz by z, and what we will have left with uz by z will be equal to 5z minus 2 divided by z minus 1 to the power 4. This we will break into partial fractions, but we will write it in the partial fraction in such a way that we can easily get the z inverse z transform. So, z minus 1 to the power 4. Okay. Now, let us see how we do this. So, uz by z is 5z minus 2 divided by z minus 1 to the power 4. Now, there will be 4 fractions corresponding to z minus 1 to the power 4. There will be z minus 1 over z minus 1 over z minus 1 square. Okay. So, z minus 1 square, z minus 1 cube, z minus 1 to the power 4. Now, for z minus 1 you need only z in the numerator. Okay. That z is here. So, we will multiply in the end and we will have a times z over z minus 1. We can easily write the inverse z transform. For z minus 1 whole square you need to have a z. Okay. Since a is 1 you need to have z, and z we will get from here. So, b times z over z minus 1 whole square can also be easily inverted. Now, here we have z minus 1 whole cube. For z minus 1 whole cube you use this formula, z transform of n square a to the power n, and this gives you z transform of n square as a equal to 1. Okay. So, z square plus z divided by z minus 1 to the power 3. Now, 1 z from the numerator we have already taken, and in writing to write uz over z. So, what we need here is that z plus 1 we need in the numerator. So, we write c times z plus 1 over z minus 1 whole to the power 3, and corresponding to z minus 1 to the power 4 you need this formula z of n cube. Now, z of n cube over the value of z of n cube can be found easily from the recurrence relation for z of n to the power p. If you recall, z of n to the power p, we had proved this one. P is a positive integer. We have shown that minus z d over dz of z of n to the power p is z of n to the power p plus 1. Okay. So, if you know the value of z of n, you can find the value of z of n square. If you know the value of z of n square, you can find the value of z of n cube. So, from here you can see z of n cube will be equal to minus z d over dz of z of n square. Okay. Z of n square we know. So, z of n square is this one. Okay. Z square plus z over z minus 1 whole cube. So, z is d over dz of z square plus z divided by z minus 1 whole cube. Okay. So, you can differentiate this. Okay. This will give you minus z times 2z plus 1 into z minus 1 whole cube minus 3 times z minus 1 whole square into z square plus z divided by z minus 1 to the power 6. We can cancel z minus 1 whole square to have 2z plus 1 into z minus 1 minus 3 times z square plus z divided by z minus 1 to the power 4. Okay. We have cancelled z minus 1 whole square from the numerator and denominator. So, we get minus z times 2z square plus z minus 2z minus 1 minus 3z square minus 3z divided by z minus 1 to the power 4. Okay. What we get? 2z square minus 3z square. So, we get minus z square. Okay. And then we get here z minus 2z is minus z, minus 3z is minus 4z. Okay. And we get minus 1 divided by z minus 1 to the power 4, and this is z cube plus 4z square plus z divided by z minus 1 to the power 4. Okay. This is what we have taken here. Okay. So, what we will do now, 1 z we have already extracted from the numerator to write u z by z. So, we need on the right side z square plus 4 z plus 1 divided by z minus 1 to the power 4. So, this coefficient of z we have taken, coefficient of d we have taken, z square plus 4 z plus 1 over z minus 1 to the power 4. Okay. Now, we can see that we have z minus 1 to the power 4. Okay. So, here what we do, we can get the value of d directly. Okay. The value of d can be found directly. You put z equal to 1. This is identity equation. Okay. This identity. Okay. It is true for all values of z. So, in this you put z equal to 1. Okay. What you get? Minus 3 equal to, this will be 0, this will be 0, this will be 0. So, we will get d times 6. So, we get d equal to no, this is plus 3. Okay. So, we get d equal to half. Okay. 5 minus 2 is 3. Now, equating coefficient of z cube both sides. Let us equate the coefficient of z cube both sides. This is the term which has a term in z cube. Here we do not have a term in z cube, here also, and here also we have no term in z cube. So, the coefficient of z cube is a here, and here the coefficient of z cube is 0. So, we get a equal to 0. So, we get the value of d and the value of a. Okay. Now, let us equate the coefficient of z square both sides. So, here there is no term in z square on the left side. So, we get 0, and there the right side the coefficient of z square, if you collect, you get minus 3a plus b plus c plus d. So, you get this equation, minus 3a plus b plus c plus d equal to 0. This is one equation, and when you equate the coefficient of z both sides, here the coefficient of z is 5, on the right side the coefficient of z is 3a minus 2b plus 4d. So, we get 3a minus 2b plus 4d equal to 5. Okay. Now, equating the constant term both sides, here the constant term is minus 2, here the constant term will be minus a plus b minus c plus d. Okay. So, we have minus a plus b minus c plus d equal to minus 2. Okay. Now, solving 7, 8 and 9. Okay. 7, 8 and 9, we know the values of a and d, we can put them, we get the value of b and c, b equal to minus 3 by 2, c equal to 1. So, we get u z. Okay. U z equal to minus 3 by 2, minus 3 by 2 is the value of b. Okay. A is equal to 0. Okay. So, this term becomes 0. So, minus 3 by 2 z minus 1 whole square, z over z minus 1 whole square plus c is equal to 1. Okay. So, we get z square plus z divided by z minus 1 whole cube, and then we have d equal to half. Okay. So, we get 1 by 2 z cube plus 4 z square plus z divided by z minus 1 to the power 4, d equal to half. Okay. So, this is plus half, here we have minus 3 by 2 z over z minus 1 whole square plus z square plus z over z minus 1 whole cube plus half z cube plus 4 z square plus z over z minus 1 to the power 4, and now take the inverse z transform. Okay. So, inverse z transform of u z, z inverse of u z we have to find. Okay. This is equal to u n. Okay. So, u n will be equal to minus 3 by 2. Okay. This is z transform of n. Okay. Z transform of, so minus 3 by 2 into n. Okay. Plus this is z transform of n square. Okay. Z transform of n square is z square plus z over z minus 1 whole cube. So, you get n square here. Okay. And this is z transform of n cube. So, minus 1 by 2 n cube. So, this is plus 1 by 2 n cube. Okay. So, what we can do, this is 1 by 2 n times, we will have n square plus 2 n plus 3 minus 3. Okay. So, this will be having factor 1 by 2 n plus 3 into n minus 1. Okay. So, u n will be equal to 1 by 2 n into n plus 3 into n minus 1. Okay. This. All right. So, this is how we solve the this difference equation. We have seen that there were some complicated rational functions, and we had to use some we had to write the partial fraction in a particular form, so that we can easily take the inverse z transform. I think now this how we have to solve the given difference equation and how we have to find the inverse Z transform there, this thing must have become clear to you. With this I would like to end my lecture. Thank you very much for your attention.